All right, guys, so it's the end of quarter three, time to prepare for our quarter three final. So just like the other videos, I don't expect you to sit through and watch this entire review, but find the problems you're struggling with and watch what you need to relearn what you need to do to solve the problems. So number one, it says that the blue figure is a dilation image of the black figure. So the blue is the new image because it's a dilated figure of the old black one. The labeled point is the center. Tell whether it's an enlargement or reduction. Again, hopefully that's an obvious one. The blue shape is smaller than the black shape, so it's a reduction. And then it wants the scale factor. And remember, to find the scale factor, you measure part of the new shape and divide it by part of the old shape. So I would pick the easiest side that you can. So for me, I'm going to measure this side right here of the blue shape, and that is 2 long. So I'm going to put 2 on top. Now that same side for the black shape is 1, whoops, where'd my pen go? 1, 2, 3 long. So that goes on the bottom. So my scale factor is 2/3. Number 2, a dilation has center 0, 0. Find the image of the point L, -5, 0 for the scale factor 2. So the language of this one might be a little bit confusing. You have a point on the graph, -5, 0. So you're at -1, 2, 3, 4, 5. You're right here at -5, 0. And it's going to take that image and dilate it. And it wants to know, where is that new point going to be? This point that's at -5, 0, where's the new point going to be when I dilate my shape? All you have to do is take the scale factor and multiply it by the x and multiply it by the y. So 2 times -5 tells me that my new x value is going to be -10. 2 times 0 tells me that my new y value is still going to be 0. It's not going to change because 2 times 0 is 0. Number 3, what's the value of x in simplest radical form? So you have 2 sides of a right triangle. You're looking for the third side. So your hint is that you're using the Pythagorean theorem, right? We've got a squared plus b squared equals c squared. So c is always my hypotenuse. The other two, it doesn't matter which one is a and which one is b. So when I plug these into my formula, my Pythagorean theorem, I get 16 squared plus 12 squared is equal to x squared. And then it wants me to simplify and keep my answer in radical form. So I'm just going to railroad track to solve for x. So the first thing I'm going to do is 16 squared plus 12 squared, which, what do we got? 16 squared plus 12 squared is going to give us 400. So I'm going to end up with 400 equals x squared. Now to get x by itself, it doesn't want x squared, it wants x. So I've got to square root both sides. So I'm going to take the square root of 400, and I get 20. So x is equal to 20. Now, if it had not been a nice number, let's say that you had ended up with like square root of 72, that's an acceptable answer. If it comes out as an ugly decimal, don't give me the ugly decimal when it says type an exact answer. It wants you to leave the square root in there if it's an ugly number, okay? And we might see that on this next one. So find the value of x. Again, I'm going to use the Pythagorean because I have 2 of my sides and I'm looking for the third side. So in this case, my c is going to be 8. The a and the b, again, it doesn't matter which one is which, but I'm still going to use a squared plus b squared equals c squared. So when I plug these in, a is 3, so 3 squared plus, this time I don't know what my b is. That's my x. So 3 squared plus x squared is equal to c squared, which is 8 squared. So that means that 9 plus x squared equals 64. Now I railroad track because I'm trying to get x by itself. So I've got 9 plus x squared equals 64. To get x by itself, I'm going to minus 9 from both sides. So I get x squared equals 55. And this is not going to be a nice number because when I square root both sides, look what happens. When I take the square root of 55, I get 7.416. I get a great big, long, ugly number. So what it wants you to do is leave it as root 55. Because look at the answer right here. It says to type an exact answer. So don't put the decimal, put square root 55. That would be an acceptable answer for that one. Leave it as a radical. That's not always going to be the case. Some of the problems are going to want you to round. You just have to pay attention to what it's asking you, how it wants you to put the answer in. Okay, number 25. We're going to use these same ideas, but this time it gives us a story problem. So it says that a 25-foot ladder is placed against a vertical wall of a building. All right, so I have a wall of a building here, and then I'm going to take a ladder and lean it against that building. And I know that the ladder is 25 feet long. The bottom of the ladder is standing on the ground 23 feet from the base. So the bottom of the ladder is 23 feet away from the base of the building. How high up the wall does the ladder reach? Okay, well, hopefully this building is straight and we get a 90-degree angle there, and it wants me to find the height of the building. How far up is the ladder going to go? So, first of all, this is a scary ladder because it's only 25 feet long and you're 23 feet away from the building. Clearly, they weren't very careful how they put these numbers in. So, Pythagorean Theorem, a squared plus b squared equals c squared. This is my c because it's across from the hypotenuse. We'll call this a, and our h can be our b. So I've got 23 squared plus h squared equals 25 squared. Okay, so 23 squared is what? 529. 25 squared should be 625. So 529 and 625. So 529 plus h squared equals 625. So if I minus 529 from both sides, then I end up with h squared equals, what are we going to be? We're going to be at 94. Nope, not 94, 96. Bad math, Mr. Reed. We're going to be at 96 because you take away 29, then you take away the 500. So h squared equals 96. To get h, I'm going to square root both sides. So I'm going to take the second square root of 96, and I get 9.7979. So we get what? 9.7979. Now it says to round to the nearest hundredth this time. So my hundredth is this place right here. So my 7 tells me to round up, which makes this a 0, which makes that round up to an 8. So my answer is going to be 9.8. So you're only 9 feet up the wall. All right. Number 6. Use the given right triangle to find the ratios in reduced form. So all we're doing on this one is writing the ratios. We're not solving anything, but it wants me to use angle A right here. So first thing I'm going to do when I'm writing my ratios is label. Across from the 90 degrees, that's my hypotenuse. Across from my angle is the opposite side. And what's left over is my adjacent side. Then I just need to remember Sohcahtoa. Okay. The sign of A, sign tells me to use O and H, which is the opposite over the hypotenuse. So 7 is going to go on top. 25 is going to go on the bottom. Cosine tells me to use the adjacent and the hypotenuse. Well, my adjacent is 24, and my hypotenuse is 25. Tangent tells me to use the opposite on top and the adjacent on the bottom. So I'm going to put 7 on top and 24 on the bottom. Now, it does tell me to reduce if possible. None of these reduce. They might on your question, but on my question, none of them reduce. So those would be my answers. Okay, number 7, find the measure of side B. All right, so looking at this triangle, it gives me an angle right here. Angle A is 31 degrees, and it wants me to find B. So I know I'm going to use sine, cosine, or tangent, but I need to label my triangle first to figure out which one to use. So across from the 90, there's my hypotenuse. Across from my angle is the opposite side, which makes this bottom one be the adjacent. So when I think about Sohcahtoa and the fact that I have my hypotenuse and I'm looking for the adjacent, so I want to know what uses hypotenuse and adjacent, what uses A and H, and it's the one in the middle, it's the cosine. So what I want to write down is my trig ratio for cosine. So I write the cosine of my angle, and my angle is 31 degrees. So my cosine of 31 degrees is equal to the adjacent goes on top, so B goes on top. The hypotenuse goes on the bottom, so 260 goes on the bottom. Now this problem wants me to solve for B. So when I do my railroad tracks, I'm trying to get B by itself. And right now I've got B divided by 260. So I need to times both sides by 260. So this means, now when I put this in the calculator, I want to be careful that I put the 260 in the front of the cosine, not after the cosine of 31, because sometimes it'll times the 31 and the 260 together. But I don't want it times by 31, I want it times by the cosine of 31. So I'm going to go to my calculator. I'm going to click on mode and make sure I'm in degree mode. And then I'm going to type in 260 cosine of 31 degrees. And when I hit enter, it tells me 222.8634. So 222.8634. Now, before I type in my answer, I'm going to look at my parentheses. Round the answer to the nearest whole number. So 222.8 tells me that I need to round up to 223 inches. So I'm going to put 223 inches as my answer for B. Okay, number 8, find the value of X. Well, this time I'm looking for an angle. Okay, it doesn't give me the angle, but it does give me two sides of the triangle. So that means that I can use Sohcahtoa. Hopefully you notice a pattern on this test because you're going to be using Sohcahtoa on almost every problem that you do. So if this is my angle, the first thing I want to do is label the triangle. So across from the 90 is my hypotenuse. I'm using this angle as my angle, so across from X is my opposite, which makes the 5 my adjacent. So when I think about Sohcahtoa, I've got adjacent and opposite. So I'm looking for what uses A and O, and that's going to be the tangent. So what I write down when I write my trig ratio is the tangent, and we need to put an angle after tangent, but I don't know the angle. It's X, so that's where my X goes. So tangent X equals, Sohcahtoa tells me to put opposite on top, adjacent on the bottom. So I get 9 over 5. Now I'm not done because it wants the value of X. And right now, X is stuck to the tangent. And remember, to get X unstuck from tangent, we have to use the inverse tangent on both sides. If I do it to the left, I've got to do it to the right. So that's what cancels out my tangent, which leaves me with X. Now on the other side, I did tangent inverse, and I've got 9 over 5. So what's going to happen on my calculator is I want to plug that in because it's asking me to find x, and it wants me to round to the nearest degree. So on my calculator, instead of hitting the tangent button, I'm not using tangent, I'm using inverse tangent, which is right above tangent in blue. So I hit second tangent, and I need to put 9 over 5. So I'm taking the inverse tangent of 9 over 5. And when I hit enter, it tells me 60.94 is what that comes out to be, 60.94. And it wants me to round to the nearest degree. Well, 60.9 rounds up to 61. So my answer would be 61 degrees. Okay, number 9 looks a lot like what we just did. I'm looking for an angle, but this time it gives me different sides of my triangle. So first thing I'm going to do is label. Across from the 90 is my hypotenuse. Across from my angle is the opposite, which means that the 4, what's left over, that's my adjacent side. So when I think about Sohcahtoa, I've got hypotenuse and adjacent. So what uses A and H, and that's going to be the one in the middle, cosine. So I'm going to write that trig ratio. Cosine of an angle, I don't know my angle, that's what I'm looking for. So cosine x is equal to the ratio of my sides, which is the A on top, 4, over the hypotenuse, 6.4. And hopefully you're noticing the pattern. If you're ever looking for an angle, you're always going to use this inverse button because I've got to get rid of the cosine in front of the angle or the tangent in front of the angle. So if you're ever looking for an angle, you should know that you're going to end up using that inverse button to find your answer. If you're looking for a side of a triangle, you'll just use the regular sine, cosine, or tangent. So inverse cosine of 4 over 6.4. So in my calculator, instead of using cosine, I'm going to do second cosine, and I already forgot my numbers. 4 over 6.4. So 4 divided by 6.4. And I get 51.317. So this is 51.317. And before I type that in, round to the nearest degree. So 51.3 is going to round to 51. Okay. Number 10, here's a right triangle. I know it doesn't show the right triangle in the symbol down there. On this test, assume it's a right triangle if it looks like a right triangle. For some reason, this problem doesn't give you that little symbol in the corner. Again, I'm using a right triangle. I know an angle. I know a side. So I know that I'm going to use Sohcahtoa to solve for what I don't know. So this is my angle. And if I label the triangle across from the 90, there's my hypotenuse. Across from my angle is the opposite. And the last leftover one is adjacent. So thinking about Sohcahtoa, I need to use opposite and adjacent. The hypotenuse doesn't matter because I'm not using it in this one. So what uses O and A is going to be your last part, tangent. So my trig ratio, I'm going to use tangent, and then I need my angle, which is 35, is going to equal the opposite side, x, divided by the adjacent side, 44. So to get x by itself, I just railroad track. The opposite of dividing by 44, I need to times both sides by 44. And I'm going to be really careful that I put that 44 in front of the tangent, not after the tangent, when I plug it in my calculator. So 44 times the tangent of 35. So 44 times the tangent of 35, enter, gives me 30.809. So that's 30.809. Now before I type it in, round to the nearest hundredth. So this is my hundredths. So I'm going to look at the 9, which tells me to round up. So 30.81 would be my answer. All right, number 11. I bet you can't guess what we're going to use to solve number 11. Find the value of x. Oh, weird. We're using Sohcahtoa again. I hope you're catching on to this pattern. This is the big idea, this entire chapter. This is what you need to know how to work with, which is why it keeps coming up and it's going to keep coming up. So, again, I'm looking for the angle. I've got two of my sides, so let's start by labeling. Across from my 90 is I started writing opposite. It's not, it's the hypotenuse. Across from the x is the opposite, which means this one down here is adjacent. So when I think about Sohcahtoa, I'm using hypotenuse and I'm using opposite. So I'm using O and H, which means I need to use sine. So sine of an angle. Well, my angle is x. I don't know what it is. So there's x. Sine of x equals, the opposite goes on top, 12. The hypotenuse goes on the bottom, 31. Now remember, when you're looking for an angle, we end up using the inverse functions, right? Because to get rid of sine, I've got to do sine inverse to make that go away. But if I do it to the left, I've got to do it to the right. So I use sine inverse on the right of 12 over 31. Okay? So plugging that in my calculator, instead of sine, I'm using inverse sine, and I'm doing 12 divided by 31. So 22.773. So that becomes 22.773. Now, before I type that in, round to the nearest degree. So 22.7, the 7 tells me to round up to 23. My answer is going to be 23 degrees. Okay, number 12. We're going to use Sohcahtoa. Find the measure of angle B. Now this one, if you look at number 12, it wants me to solve the right triangle. And what that means, if you don't remember, is to solve all of the pieces of the triangle. We need to know all of the angles and all of the sides. And it kind of gives you a hint what's the easiest thing to do first, because look at what it tells me to do first. Find the measure of angle B. So I'm looking for this angle first. Well, I know that the angles of a triangle add up to 180 degrees. And this right here is already 90 degrees. And A is 33 degrees. So all I have to do to figure out the last angle is 180 minus 90 minus 33. And that's going to give me my angle, which becomes, 57? So angle B is 57 degrees. Well, I probably shouldn't put the degree symbol. It already has it there. So 57. That's angle B. Then it wants me to find the length of A and the length of C. So I'm going to start with, now I know that this is 57 degrees, but just in case I did something wrong, I want to use the angle that they gave me because I know that that number is accurate. I know that that 33 is the correct number. So I'm going to use that angle and I'm going to label my triangle. So across from the 90 is my hypotenuse. So C is going to be my hypotenuse. Across from the 33, that's my opposite side. So A is going to be opposite, and that means 16 is the adjacent. So I want to use Sohcahtoa, and I want to set up a trig ratio to help me find the sides that I don't know. And again, I'm going to use their hint to start with A. So the first thing I'm looking for is the opposite. Now I know the hypotenuse is C and the adjacent is 16. The hypotenuse isn't going to help me find the opposite because I don't know what it is, but the adjacent will because I know that the adjacent is 16. So I'm going to use opposite and adjacent, which tells me that I need to use tangent. So my ratio, when I write out my trig ratio, is going to be the tangent of my angle, 33 degrees, is equal to the opposite side, so A, divided by the adjacent side, 16. Now that I have it set up, I just get a by itself. So I just multiply both sides by 16, and I remember to put the 16 in front of the tangent when I type it in the calculator. So we're going to go calculate 16 times the tangent of 33, which gives me 10.39. So A is 10.39. Before I type it in, round to 1 decimal. So it just wants 1 decimal. So when I look to the right, that tells me I need to round up to 10.4. So A is 10.4. Now I need to find C. Now to find C, which is my hypotenuse, I could use A now that I know what it is, but what if I did it wrong? And not only that, but I rounded A, so I don't want to use A. I want to use adjacent. I want to use the 16 because I already know that that is the correct answer for the adjacent. So I'm going to look for the trig function that uses adjacent and hypotenuse. So what uses A and H? That's this one in the middle, cosine. So I'm going to write cosine and then my angle, 33, equals cosine wants adjacent on top and hypotenuse on the bottom. And I think this is the first one on the review where when we do our railroad tracks, our exponent, our variables on the bottom. Now remember the trick. When you have a variable on the bottom like this, the trick is that all I have to do is take cosine of 33 and C, and they're going to swap places. Okay, so instead of cosine 33 on the left, I'm going to put the C there, and the 16 stays on top, but instead of C on the bottom, I'm going to move the cosine 33 to the bottom. So C is equal to 16 divided by the cosine of 33. So I go to my calculator and I do 16 divided by the cosine of 33. And I hit enter and it tells me 19.077. So that's 19.077. And again, it wants 1 decimal. So 19.1. That 7 tells me to round it up to a 1. Now you've solved the entire triangle. You know all the sides and you know all of the angles, okay? All right, number 13. Solve the right triangle. So this is a lot like number 12, but in this one, to start out with, it gives me 2 sides. It doesn't give me any of the angles. It just gives me 2 sides. Well, except for the 90 degrees, but it has to give us that. Otherwise, we don't know anything. So it gives me a hint. Start by finding the measure of angle A. It doesn't really matter what order you do this in, but we're going to follow their recommendation. I'm looking for angle A, which is right here. So to find angle A, I need to label my triangle. So this is my hypotenuse. Now when I label my triangle, I'm basing my labels off of angle A because that's what I'm looking for. So 11.4 is my opposite because it's across from angle A, and that means 6.9 is my adjacent. Okay? So to find angle A, I've got adjacent and opposite. So when I think about Sohcahtoa, what uses adjacent and opposite? And that's going to be the last one, tangent. So I write down tangent of my angle. I don't know what my angle is. That's what I'm looking for. So tangent of my angle A is equal to the opposite side, 11.4, divided by the adjacent side, 6.9. Now I need A by itself. So I railroad track. And to get rid of tangent, since I'm looking for an angle, I'm going to have to do the inverse tangent because that's what makes tangent go away and leaves A by itself. But if I do that to the left, I've got to inverse tangent the right side as well. So I get an inverse tangent that goes in front of that 11.4 divided by 6.9. So all I need to do is plug that in my calculator. So I go to my calculator and instead of hitting tangent, we're doing inverse tangent of 11.4 divided by 6.9, I think. Did I remember the numbers right? 11.4, yeah. divided by 6.9. So 58.815. So this becomes 58.815. Now when I look, before I type it in, round to 1 decimal place. So 58.8 or 58.9. Well, that 1 tells me just to round to 58.8. All right, now to find angle B. Now that I know angle A, I'm looking for angle B. And there's a couple of different ways that we can do this. You can start over and you can use angle B to label the triangle and find what angle B is. But there's a shorter way because I know that the angles of a triangle add up to 180. So if this is 58.8 and if this is 90, it's really easy to figure out what B is. All I have to do is take 180 minus 90 minus 58.8, and I'm going to end up with 31.2. Right? Yeah, right. 31.2. So angle B is 31.2. All right, now it tells me to find length C. So let's get rid of some of this mess right here. And it wants me to find C. So what I've seen a few people do on this one is, you know how we found these two angles? You know, they want to use Sohcahtoa to find C. But in order to do that, I'm going to be using numbers that the problem didn't give me. And if I made a mistake, then I'm going to make another mistake by using that number. So what I would rather do is use the Pythagorean theorem, because I know that a squared plus b squared is always equal to c squared. And I have an a right here and a b right here, and my hypotenuse is what I'm looking for, and that's my c. So I can say 6.9 squared plus 11.4 squared equals c squared. So let's add those together. 6.9 squared plus 11.4 squared gives us 177.57. So 177.57 equals c squared. Now, I don't have c alone yet. I've got to square root both sides. So my answer, round to 1 decimal. Okay, so I do get to get a decimal. I'm going to take the second square root, 177.57, and it tells me 13.325. So this becomes 13.325, but it wants 1 decimal. So I'm going to round that to 13.3, which might be a little bit different if you had tried to use Sohcahtoa to find the hypotenuse. So be really careful when you're doing these triangles. If possible, use numbers that they gave you, not numbers that you found yourself. Okay, number 14. At a certain time of day, the angle of elevation of the sun is 80 degrees. To the nearest foot, find the height of a tree whose shadow is 44 feet long. Okay, so this story problem gives you a picture to go with it. So it kind of draws the triangle for you, and not only that, but it labels it for you. So you have this triangle. It tells you the angle of elevation is 80 degrees, and it wants us to find the height of the tree. So I'm just going to treat this like any other triangle problem, and I'm going to label it first. Across from the 90 right there is my hypotenuse. Across from the angle that it gave me, we're going to call that the opposite. And this one down here is going to be our adjacent side. So I think about Sohcahtoa. And I don't care about the hypotenuse because I'm looking for the opposite and I know the adjacent. So I'm going to use tangent. That uses O and A. So I'm going to write down the tangent of my angle, which is 80 degrees, equals the opposite, H, divided by the adjacent, 44. And then I'm just looking for H. So I just railroad track. I multiply both sides times 44. And I remember to put it in front of the tangent so my calculator doesn't give me the wrong answer. And I go to my calculator, 44, tangent of 80, I hope, of 80 degrees, 249.536. 249.536. Now, before I type that in, simplify your answer, round to the nearest whole number. So this 5 tells me that that 9 needs to round up, which means that this needs to round up. So 250 feet is how tall that tree is. It's 250 feet tall. All right, next story problem. Again, it's going to give you the picture, which is hopefully just helping you get ready for the next one where you're going to have to do that yourself. So this one says that a tower is 159 feet tall and it has a 164-foot shadow. Find the angle of elevation of the sun. All right, so I'm looking for, again, it draws the triangle for you. So we're just going to treat this like any other right triangle, and I'm going to label it hypotenuse. This is the angle that I'm using, so that makes 159 the opposite, and 164 becomes the adjacent, okay? So I'm looking for A, and when I think about Sohcahtoa, I'm looking for the opposite, and I have the opposite, I have the adjacent. They're going to help me find angle A. So what uses O and A? Tangent, the TOA. So tangent of an angle, I don't know the angle, that's right here, that's A, is equal to the opposite side, 159, divided by the adjacent side, 164. Now, if you remember the other problems, to get A by itself, to get rid of tangent, I have to do tangent inverse to both sides. So if I tangent inverse the left, it goes away and I'm left with A. And then I tangent inverse the right and I get 159 over 164 in there. And I got to plug that in my calculator. So I'm going to go to my calculator, and instead of tangent, I'm going to do inverse tangent of 159 divided by 164. I think 44.11. 159 and 164, was that right? Yeah. Okay, so 19, no, where'd my answer go? 44.11. So this becomes 44.11. And before I type that in, round to the nearest degree. So 44.1 rounds to 44 degrees. All right, number 16. Now, this is something you should absolutely expect on the test. In fact, you should expect a few problems like number 16, where it's a story problem because this is where the sine, cosine, and tangent, Pythagorean Theorem, this is all such powerful stuff that you can use in real life. But when you look around the world, you don't see these right triangles drawn for you. You have to draw them yourselves. So number 16 says that a hot air balloon is flying at an altitude of 248 feet. So what that means is I've got this hot air balloon, right? And it's flying at an altitude. Altitude is its height. So the height of this hot air balloon is 2,048 feet. Then it says if the angle of depression from the pilot in the balloon to a house on the ground. So you've got a house on the ground over here, and the pilot is looking down at the house. But it's looking down at an angle of depression. Well, what an angle of depression means is if you are looking straight ahead, an angle of depression is the angle that you would be looking down instead of straight ahead. So in this picture, if the person in the balloon, let's draw the person in the balloon. The person in the balloon, if they're looking straight ahead and they look down at the house, it creates an angle of 28 degrees. Okay? So there's a couple of different ways you can work this problem from here. It wants to know how far the house is from the pilot. So it's actually looking for this distance right here. What's the distance from the house to the pilot? Now, I can draw two different triangles to solve this problem. I can draw a triangle right here, and make this my 90 degrees. Or, if I want to, I can draw a triangle right here and make this my 90 degrees. Either triangle works, you just have to be careful about your numbers. I would prefer to use this red one because I already know that this angle is 28 degrees and it's inside that red triangle. And then all I have to do is transfer the information from this triangle to the other. Like, for example, this length right here is the same as this length right here. So I can say that this is 2048. This I don't know, I don't care about, but my x is still x. It's just the hypotenuse of my triangle. So let's think about Sohcahtoa. How is that going to help us solve this triangle? Well, first of all, let's label it. Across from my 90, there's my hypotenuse. Across from my angle, there's my opposite. And that makes this nonsense up here the adjacent, which I don't really care about right now because that's not going to help me. What I do care about is the hypotenuse and the opposite because I'm looking for one of them and I know the other one. So what uses O and H? Sine. So my ratio that I write, I'm going to write the sine of my angle, which is 28 degrees. The sine of my angle is equal to the opposite side, 2048, divided by the hypotenuse, which is x. And if you remember the shortcut, when this happens, all you have to do is switch the x and the sine of 28 with each other. So it becomes x equals 2048 divided by the sine of 28. You'd plug that in your calculator. So 2048 divided by the sine of 28, and you get 4,362.35. So 4,632.35. But before I type that in, round to the nearest tenth, which is right there. So 4632.4 would be my answer. That's how far away the balloon, the guy in the balloon is from the house, okay? You need to know how to set up this problem. You need to know how to draw a picture. You need to know what an angle of depression is because those things are going to help you set up your own story problems when it comes time to take the test, okay? For example, if you've stuck with me this far through the video, there's a chance that you're going to see something on the test that looks similar to this, okay? We're going to do one more bonus problem. What if, let's say something like, let's use a coordinate grid, okay? So we're going to say on a coordinate plane, which is just the XY axis, right? That's a coordinate plane. We're going to say let's say point A is at, I don't know, 0, 15. And point B is on the x-axis. Okay, so if I start drawing this picture, point A is up here at 0, 15. And point B is, let's call that A. Point B is over here somewhere. We don't know. Let's give ourselves an angle. So if I say that the angle, let's say that the angle of depression from A to B is, let's call it 70 degrees. Okay, what that means is if angle A was looking straight across and then it looked down to angle B, that angle that we created right here would be 70 degrees. Okay. And then let's ask you a question. What is point B? If I want to know what's the point B. All right, so again, we have a couple of different triangles that we can draw. I see this one right here, and let's go straight down to B so that we make a 90-degree angle right here. Now, what do I know about my picture? I know that this point is at 0, 15, which means this distance right here is 15, which also means that this distance right here is 15. Okay, so now I know an angle and a side. That helps. I'm looking for this point. I'm looking for this point, which, nicely enough, it's on the x-axis. We just need to know how far over it is. So basically, I'm looking for this length right here. How far over is that point? Because I know the 0 value. I just need to know how far over it is. And I've got a triangle. So now that my problem's pretty simple, let's label hypotenuse, opposite, and that makes this the adjacent. So I'm looking for the adjacent, and I know the opposite. All right, well, Sohcahtoa tells me opposite and adjacent. That means I need to use the tangent. So the tangent of my angle, 70, equals the opposite side, 15, divided by the adjacent x. Well, my x is on bottom. I don't like that. So let's just switch those two places. X equals 15 divided by the tangent of 70. Okay, I can plug that in my calculator. 15 divided by the tangent of 70. And I get 5.45955. 5.4, let's see, 5.45955. Well, let's round that to one decimal. So let's say that that is 5.5. So that means that this distance right here is 5.5, which is kind of cool because that means that this distance right here is also 5.5. So now I know my point because my point B is over 5.5 and it's up and down 0 because it's on the x-axis. So I know it's not up and I know it's not down. Okay. So this idea, this Sohcahtoa, this Pythagorean theorem, lets you solve all sorts of problems, whether it's on the coordinate graph, whether it's in real life. It gives you a lot of powerful tools that you use. In fact, from here, we could say, well, what's the distance between A and B? Well, that's just my hypotenuse, which I can find because I know the adjacent, I know the opposite, I know an angle, so I can use Sohcahtoa, or I can use 15 squared plus 5.5 squared equals my hypotenuse squared. I've got multiple ways to solve that problem now. Either, whatever it is, when you know an angle and you know a side length, you can find everything else you need to know about the triangle. Okay, so make sure you can work through these problems without my help. Make sure that you can solve them start to finish by yourself so that you're ready for your quarterfinal on Wednesday.